Hello and welcome to the 25th Vermont Grazing and Livestock Conference. I would like to take a moment to thank our sponsors. I would like to thank the National Grazing Lands Coalition, Food Animal Concerns Trust, Morrison's Custom Feeds, Rural Vermont, and the Vermont Agency of Agriculture, Food and Markets. I would also like to thank our partners. I would like to thank the United States Department of Agriculture, National Institute of Food and Agriculture, and the National Resources Conservation Service. I would also like to thank Cedar Tree Foundation and the Forrest C. and Francis H. Latner Foundation. Thank you for joining us for the 25th Grazing and Livestock Conference. The conference is brought to you by the University of Vermont Extension Center for Sustainable Agriculture and the Vermont Grass Farmers Association. Enjoy the content. Hello, everybody, and welcome. I'm Megan Sheridan. I'm the Executive Director of the Vermont Grass Farmers Association. I'm going to turn this over to Emily, who is going to facilitate this session. You are all in the soil samples for Hay Fields and Pastures. Emily, you're going to unmute yourself and take it from here.
Hi, everyone. I'm Emily Finnegan. I'm a member of the VGFA board, and I work for the Orleans County Natural Resources Conservation District. So you're in soil samples for hay and pasture, why sample, and what to do with the results. And we have two folks with us here today to help us with this. Laura Johnson works for the University of Vermont Extension's Center for Sustainable Agriculture, and she's an agronomy outreach professional and certified crop advisor. And her work focuses on farm-focused technical assistance and programming related to soil health, forage crops, and water quality. And we also have with us here today Maggie Borders, who recently completed her AmeriCorps service with UVM Extension, where she was working with Laura at the Center for Sustainable Agriculture. And I will turn it over to Maggie.
All right, hi everyone. So we're going to go ahead and get started. 1 second, I'm going to start sharing my screen. So, as Emily said, welcome to Soil Sampling for Hay and Pasture. My name is Maggie. I'm going to be doing the first half of this presentation, and Laura will be doing the second half. So here's the agenda for the first half. We're going to go pretty quick, but just know that this will be available to you after the fact, along with the whole PowerPoint. There's tons of notes and resources at the end, so I would encourage you to take a look at it after we're done presenting here. So let's get started. The first thing we're going to talk about is soil sampling, and you might think this is something that you do outside, but we're actually going to start at your desk. So the first thing you need to do before you even go and soil sample is understand your land, and that's really important. You're going to want to subdivide your property into different sampling zones so that you get results that are representative of each zone, and you can interpret them to apply nutrients as you need and actually make them usable. Generally speaking, this is best done using topographical data, but it can also be done using other things like soil type. So as an example, we have this image here, and you can see pretty clearly that the area has been subdivided into zones based on slope or topography, relief, whatever you want to call it. This is a really common way of doing things. It's really easy, but it's also possible that it may just differ based on soil type or texture. So in this example, that large flat area is subdivided into 3 different samples that aren't really topographically different in topography terms, but they might be different in soil type. And so it's really important that you subdivide those. You can use, if you're not familiar with your land yet, you can use online tools like Web Soil Survey, or Vermont A&R Atlas to find out what soil types may be present in your field. And we'll go over that a little bit more later. Or you can go outside and just take a look around and see what looks different from what and subdivide from there. So now that you've got your zones all figured out, you're going to want to pick a day to sample. It's really important that this is consistent from year to year because it's just one less variable in your soil sample results. Typically, sampling in the autumn is best, so long after you've applied any of your amendments previously and before you're getting ready to apply or purchase amendments for the next year. You're going to want to look for a day to sample that is a couple days after rain, so the soil is moist, but it's not soaking wet. Sampling really bone dry soil is difficult. It increases the risk that you like hurt your back or just have a really unpleasant time trying to dig into really hard soil. But it's better to sample dry soil than really soaking wet soil. Soaking wet soil samples cost more to ship. They might go anaerobic when they're in the shipping container. It's just really tedious to work with. But ideally, you're going to be working with the soil when it's moist and easy to work with. Next, you're going to want to check out what equipment that you have on hand and make sure that you have what you need to sample. So the first thing you're going to need is a clean plastic sampling container. A 5-gallon bucket works great for this. Most people have one at home already. The next thing you're going to want to have is a sampling tool like a trowel, soil probe or corer. You're going to need your map or list of zones to make sure that you're sampling in the right areas, and then labeled sample baggies. And these baggies will have the name of the zone on it, as well as the date you sampled, and ideally your name as well. In this image, you can also see that there is a picture of a larger shovel, and you're going to want to avoid using something like that. It's really cumbersome. You don't get a great sample with it, and it leaves behind hazardous holes in your field where smaller sampling tools leave less of an impact on the land. So now that we're prepared, we can actually take this experience and go outside and take some samples. You're going to want to take samples in a zigzag pattern along your field, and you're not going to want to go any deeper than 4 inches. There are some nutrients in the soil like potassium and phosphorus that in no-till and pasture systems are not really mobile in the profile. So if you go deeper in the soil profile than 4 inches, your results might say that you're missing nutrients or that you need to apply more nutrients when that's not the reality. Remember to take at least 15 samples per zone.
Hey folks, I have no idea why audio went down. Maggie, can you hear us? I'm not sure whether her, hi, hi Laura. We might have to just jump into yours presentation. Not sure if her internet went down.
Okay, I can also, well, want me to do that?
Yeah, and then we'll put
Okay,
we'll put her in if she comes back. So
let me see if I can share.
we should be able to share screen.
Okay, so everybody, all right, can you see that?
Yes.
All right. And I did upload a soil sample. Is that available to attendees?
It should be in their documents. Yeah, they should be able to see it.
Okay, great. Well, hopefully you can find the soil sample that I uploaded for you all. It might be nice to have on hand if you don't have your own or you haven't yet taken any soil samples in your field. But my name's Laura Johnson, and I work with UVM Extension, like Emily mentioned in the beginning. And I'm actually going to be talking a little bit more about kind of the decision-making process after you've gotten your analysis results back, you know, where you want to go from there in terms of applications on your fields or not. So I'm going to move forward from there. And I think the first thing to think about is, do you need extra forage on your land? What does your stocking look like in your operation? Do you have something that looks like more like this field on the left where you've got 50 acres and maybe just a couple of animals, and you don't even get through all of that by the end of the season? Or do you have something that looks more like this example on the right, where you have more livestock and maybe you are in need of increasing yields to meet their needs? So I think that's the first thing to consider. And then from there, decide, do you want to follow what is recommended to you in your soil analysis? So if you decide that you've got a situation more like this one on the right, with enough animals where your forage is limited, then you might want to go from there and start thinking about which fields seem like they could benefit most from any sort of fertilizer that you might decide to add, or any other amendments that you might decide to add depending on what your soil test tells you. And where are you seeing like yellowing fields or weed issues is a way to maybe identify those areas if it's not clear on your analysis. So this, I don't know if you can see all of this. My screen is blocking part of the chart here, but the chart that I've got laid out here, this graph, is a representation of forage response to fertilizer. So along the bottom is the soil analysis level. So if you are looking at your analysis, if you've got your own, or you maybe are looking at the one that I've provided to you, on the bottom of that analysis, or sorry, at the top, there's kind of a bar chart that indicates your nutrient levels as low, medium, optimum, or high, or excessive. And that's what these indicators are on the x-axis of this chart. And then on the y-axis, we have the forage yield represented, and there aren't any numbers. It's just kind of for general idea. And then we've got a curve which indicates the response to your crop in regards to fertilizer levels or fertilizer applications. So you can see between going from low level nutrient standard, so whether it's nitrogen, phosphorus, potassium, magnesium, to medium to optimum, there's going to be a pretty stark initial crop response that it may be more clear visually and or in measuring your dry matter yields that something has improved. And then we have this optimum level where there's this optimum fertilizer rate for optimal yield, and then we have maximum yield, and there's not much of a difference here. So it may or may not be financially worth it to applying more fertilizer between these 2 points. So what mostly I want you to take away from this chart is that it's okay if you're not in this optimum range, and you may just want to go from low to medium. And that all depends on your needs. Maybe you just need a little bit of extra forage, and so you just want to apply kind of the minimal amount of nutrients. So it's really up to you and what the needs of your operation are, and how far you want to go on this curve. And then also just note that once you get into this max yield level, applying more nutrients is not going to improve your outcomes. So let me see if it goes to the next slide. There. So after you've kind of decided, how much more do you need? Do you need any more? What is that low-hanging fruit based on your soil analysis result page? So you'll see, I think it's, let me just pull it up. Oops, sorry, my screen just stopped sharing. You'll see on it, there's a pH range that, or a pH level that is given to you. And a lot of what I see is between somewhere in the 5s or the 6s. And this chart is looking at the acidity of your soil in just a few example ranges, and then the efficiency of plant availability of different nutrients at those different pH levels. So we've got nitrogen, phosphorus, and potassium on this chart listed, those being the primary macronutrients that are essential for plant growth. And so what this is just basically showing us is that pH is one component of your soil analysis that you might want to address first before you move on to, if you have to choose either or, before moving on to refining your NPK rates in your field. So you can see, like, at a pH of 5.5, your nitrogen efficiency use is just over 75%, whereas at a pH of 7, it's at 100%. So if you put $100 of nitrogen down at a 5.5 pH, you're probably throwing away $25 there. So, and then also just to note that here in our area, 6.2, the pH of 6.2, if you see that on your soil analysis, you're probably not going to see any sort of lime recommendation, which we're going to get to in just a moment, to improve that soil test or soil acidity level, because your cool season grasses are going to do just fine. But the optimum range is between 6.2 and 6.8. So pH is sort of step one, and where my eyes go to on our soil tests when I look at them first. And the way in which we're going to address our soil acidity is the two most common resources are wood ash and some sort of agricultural lime. And I do get a fair amount of questions about the use of wood ash, and I think it's a great alternative. It is a great potassium source as well. So a lot of folks see their legumes kind of pop in their fields after some wood ash applications. And so I think it's a great alternative if that's something that you are looking to use. It does take a little bit more of the product to get the same liming effect as something like an ag lime, like calcium carbonate, because its neutralizing efficiency is just less. But and I wrote a note here, it takes about 2.5 to 3 tons of wood ash to 1 ton of lime to get the same effect. But it's a great alternative. If it's wet, it can sometimes clump in your machinery and it might be more difficult to spread. But if you have ideal conditions and you can get out in your field, it does tend to be faster acting initially. And it is something you'd want to apply after you've recently cut or after you've recently grazed. So I see a question, what's the best way to spread wood ash? There are spreaders you might be able to borrow, or depending on where you are, there might be ones to rent. I know conservation districts sometimes supply those sorts of equipment. I believe where I'm in the Connecticut River Valley in Vermont, and I believe there's one on the New Hampshire side of the river that might be available. But also, depending on where you're getting your wood ash, depending on the company, they can probably come out and spread it for you. There might be, there's probably a fee associated with that, or they can drop off a spreader and you can spread it as well. Or if you're just a small operation and you've just got like a 4-wheeler with something on the back to kind of fling it out, you can do that too. It doesn't have to be big equipment. It kind of depends on what your landscape might look like. And this is just looking at the different neutralizing values of different potential lime products. And the first two I've boxed out here are two examples of ag lime, calcium carbonate and dolomitic ag lime. And those are both equally as effective. This type of lime is something that you probably won't see an effect of for 6 months to a year. It tends to be coarser material, so it takes longer to neutralize that pH, but it is longer lasting. And these are probably going to be available for you through your fertilizer dealer. And the dolomitic lime has magnesium in it as well. So if you're finding on your soil test results that magnesium is low in that low, medium, optimum bar range, then that is a great alternative. It does tend to be a little bit more expensive, but if you are lacking in magnesium, it might be a good alternative as well. And then you can see wood ash down here. You can see the efficacy is lower, which is why you need to apply more for the same effect as an ag lime. So it's not letting me advance. Here we go. So just one last note on addressing pH and with liming materials. A $40 per acre investment on ag lime may be a better way of adding fertility to fields compared to a $40 investment in fertilizer. So if you have to choose, either or, lime might be the way to start.
So
yes.
There's a quick question from Huva about wood ash and lime.
Yes.
Can you use wood ash and lime in the same year if you have soils you're trying to improve?
Yes.
Yeah.
Yes, you can. It's just a matter, you can really apply them at any time. And we usually recommend that a fall application is probably going to be best because you're probably done grazing, haying, and there aren't going to be any like major palatability issues there. But yeah, you can use them both. You're probably going to see a more immediate effect with that wood ash. And I guess in the bigger picture, you don't really want to apply more than 2 tons of lime a year. So sometimes you'll see in your recommendations that it calls for 3 tons or more, maybe. I don't think I've ever seen it more than 3, but it might say more than that. And generally don't recommend more than 2 tons a year because you're not going to see much of a difference or any of a difference in its liming effect. So I think there's only like so much that you can improve your pH over time if you're choosing to use both of those materials. Okay. So I'm going to move on to, let's see, what time is it? 11:24. So I'm going to move on to looking at the macronutrients, and maybe I'll just go through nitrogen here, and then I'll let Maggie jump back on so she can kind of go through the basics of sampling, because those are really important before, you've got to get your soil test before you can think about making these sorts of amendments or informed decisions about these amendments. So let me just go through nitrogen, and then I'll hand it back off to Maggie. So, and the reason I'm going to focus on nitrogen is because it is a fairly dynamic nutrient, and it's important to recognize that it's a short-term management tool to temporary increases in forage dry matter. So nitrogen doesn't just hang around in your soils unless it's in an organic form. And it's really what is going to give you that green, lush growth. So this is a simplified version of the nitrogen cycle. And I don't know if you can see my pointer, but we have manure and fertilizer or plant material going in, and it's going to be providing sources of organic nitrogen and also plant available nitrogen, which are in the forms of ammonium and nitrate. And then nitrogen is also lost in various ways through volatilization over here, and then leaching through your soils here, or even runoff, and then also denitrification over here. So nitrogen is very mobile within your soil solution, and you're going to see on your soil sample that it will suggest that when applying nitrogen, it be done in a split fashion. So if you're looking at your soil test report, like this one in the corner, I've highlighted just the bottom part where it has those recommendations based on your on what you mailed in. And here it's not recommending any lime, but it is recommending different levels of NPK. And just focusing on that nitrogen, it says 160 pounds per acre. And you aren't really going to want to put all of that, and this is referring to plant available nitrogen. You don't want to put all of that on up front, because you're going to lose quite a lot of that over the length of the season. And you'll see in the comments below, it will say apply nitrogen in 2 or 3 equal applications, spring and after first or second cuts, and no more than 75 pounds an acre per application. And this is for a hay field. You may not want to exceed 50 pounds per acre if it's a pasture, and that's just to ensure yield response while also not risking nitrate accumulation in the forage. And I'm not sure if anybody plans to go to the forage sampling talk, which I believe is after that, but that might be addressed there as well. But so making sure that you split this 160 pounds, if you know, or whatever your recommendation is, over time. And the best time to apply and when you're going to see the greatest response to your application is recently after it's been grazed or hayed, or at the start of the spring, and that's when you're going to really see a response at that early regrowth stage. And so referring back to those suggestions, that spring application of nitrogen, this one is a picture I took last year in April when they started spreading manure on their fields, and whatever it is that you're choosing to apply is fine. It doesn't matter if it's manure or urea or some other form. If nitrogen is nitrogen, no matter what form it's in. And by applying an early spring application, whenever it's feasible for you or your animals to get onto the fields, it can help boost growth for an earlier haying or grazing. Though it is good to be mindful that in a grazing system, consider how much growth you might get with that early spring application, because you may end up with some excess forage in your pastures by late May, which could be a potential waste of money if you're buying in nutrients, or have a plan to hay some of those fields. So looking at the next kind of suggested split application for nitrogen, that would be during an early to mid-June. And this is a representation of a nitrogen application in that time period, and what sort of yield boost you may see during that general summer slump period. So our cool season grasses are really growing in early spring, and then when it starts to get hot, they kind of slow down and shut down until again in the fall. So the white area of this chart is just what your yields may look like without an early nitrogen application, and that green area is what it would look like with an additional nitrogen application during that time period. And sorry, this is on the x-axis, we've got time in months, and then the yield in forage on the y-axis. I will say though that if it is a particularly dry year, an application at this time is probably not going to boost your yields. So if you think about what it was like this past year, really dry, droughty conditions, that you probably would not have seen with an additional application much of a or any of a increase in yields during this time period. And then finally, this last potential application period for nitrogen in early to mid-August. Again, same white here is no application, and green is the potential increase in yield. And that might be for a later grazing period in October or November. And then another way, I haven't talked too much about different types of amendments, but typically in a, hopefully probably some manure, cow manure, or some folks even use and buy in chicken manure to spread on their fields depending on the nutrient needs and levels. But don't forget your clovers. Those are great nitrogen fixing forage plants, and also really add to the nutrient value of your feed. And if you have about 30% of legume content in your forage populations in your fields, you can essentially provide all the nitrogen that is needed to the stand in a grazing system. My understanding, in a haying system, you may need to apply an additional but smaller amount of nitrogen to get the yields that you are looking for, if you're kind of looking for that optimum range. Then, but having a solid stand of clovers is a great way to manage and add nitrogen in your fields for free. And if you are seeing that maybe your clovers are lacking in your fields, you can frost seed in the late winter, early spring, coming up to try to reestablish or establish clovers in your fields to supply nitrogen in that way. And legume yields will not be limited by a lack of nitrogen. And if you start applying nitrogen at excess levels, you can actually start to outcompete those clovers, and your grasses will take over, and you making you more dependent on those inputs. So I'm going to.
Hey,
yeah.
Laura,
Yeah.
there's like a couple specific questions about
sure.
nitrogen.
Yes.
One person asked, how would an autumn / late autumn before the spreading ban application of manure impact nitrogen and other nutrient levels? That's the first one. You had like a mid-August, but I know a lot of producers probably apply in October and November.
Oh, right. So, I mean, if you've got a cover, well, we're talking a hay field, so or pasture. So some of that will be taken up by your existing plant stand, but there is not a lot of growth happening in that time period. So it may be lost to leaching and volatilization. And I haven't gotten to the other nutrients yet in my presentation. Phosphorus is a more stagnant nutrient, so it's probably going to hang around unless it runs off with a rain event or precipitation or snow melts. And potassium, any potassium, or if you're like applying wood ash at that time, it's actually a great way to, your potassium is going to be taken up by your plants, and it's going to be there still in the spring. Potassium is another one that's good to apply in split applications. You'll see that on your soil tests as well. And by a fall application, you're kind of limiting risk in terms of like milk fever in early spring forages, and calving livestock in that time period. So any potassium will also be utilized and there for your forage plants in the fall, and then again in the spring. So I think that's fine before spreading ban to apply, especially if you need to get rid of it. If you are lucky, well, most of the hay and pasture soil test results I get back are lacking in a lot of these in phosphorus and potassium, mostly because people don't have enough manure. And so if you are lucky enough to, maybe a neighboring dairy farm is trying to empty their pit and don't have any more space on their land, I don't know, and they want to spread on yours, then I think that's okay. So, but like I said, there's only a limited amount of growth in that time period to take up those nutrients, that nitrogen. Was there another question, Emily, or?
Yeah, I feel like I want to keep going and let Maggie finish with hers. And then there's some really interesting questions. So if we could leave at least like 10 minutes at least for questions at the end, that would be awesome.
Okay, I'm going to, before, let's see, what time is it? Well, I'll let Maggie go. Let me just get out of here. Stop sharing. Wait. Okay.
Thanks, Laura. All right. Hi, everyone. I'm back, which means my Wi-Fi is back. So that's good news. Okay. So we were outside taking a soil sample. Just as a quick refresher, zigzag pattern, no deeper than 4 inches. Sample each zone evenly by walking and sampling across the whole zone. You're going to need at least 15 samples, mix them in your bucket, break up any clods, and then you're going to package about 1/2 to 1 cup of sample in a label baggie for submission to the lab. And then once you've done that process for 1 sample or for 1 zone, you're going to dump out the rest of the soil that you collected, or you can save it for at-home soil texture testing. And then you're going to move on to the next zone, and you're going to do that same process for every single zone that you want to sample. So we're back inside now, samples in hand. What do? The next thing you're going to want to do is you're going to want to fill out your soil test submission form. This differs based on the lab that you use, but generally speaking, they're just going to want some information about you, where you are, and then information about your samples. So you're going to want to match the sample name to the zone name that you have on your baggies. You're going to need to know the acreage size, generally speaking, what tests you want run, and then you're probably going to need to include a check or some form of payment with your samples. Once all that's filled out, you're also going to need to include some data on what you produce on those fields. And once that's all filled out, you'll just package that form up along with your payment and your soil samples in a box, make sure it's secure, and ship it off to the lab, and that's done. So it's important to note that consistency is really key here. You're going to want to use the same zones from year to year, and you're going to want to use consistency in your sampling methodology, regarding tools that you use, depth that you sample to, when you sample, the conditions you sample under, things like that. That means that you can compare your results from year to year. It also helps to use the same lab year after year, because they do use different methods and different tests. So if you do want to use a different lab, make sure you understand what methods they use and how they differ from labs that you've used before. So we're waiting for our lab results. I was going to have you take some seconds to write down some questions that you had, but we're a little crunched for time, so I'm just going to move on. And now we're on to the next part, and this is interpreting what you get back from the lab and what else you need to know beyond what the lab results tell you to really have an accurate picture of your soil. So we're going to interpret our laboratory results. Most laboratories format their results differently from one another. We're going to be using the UVM Ag and Environmental Lab results. I've seen this format for a few different laboratories. Also, it's a university laboratory, so they're really accessible. They're not super expensive, and I think they're pretty straightforward. So here we have some soil test results. When I get soil test results, there are 2 things that I look at immediately, much like Laura said. So I look at the soil pH and the soil organic matter percentage. These are both really important metrics because they influence things like plant available nutrients and water holding capacity of the soil. So pH is going to be your master indicator As you can see in that little chart to the right, the pH level impacts the availability of nutrients. Generally speaking, your macronutrients are going to be limited at lower pH levels, and your micronutrients are going to be limited at higher pH levels. And when you get towards the extremes of the pH spectrum in soil, nutrients can start fixing one another. So basically, they make them unavailable to plants at certain pH levels. It's important, like Laura said, 6.2 to 6.8 is good for pasture and hay applications. Somewhere just under that neutral level is really good. It's also important to remember that pH is a logarithmic scale. So a pH of 3 is 10 times more acidic than a pH of 4, and a pH of 3 is 100 times more acidic than a pH of 5. That means that even small adjustments in pH can have a big impact on the nutrients and the ions in your soil. So in this example, we have two fields that are right next to each other. They're both really small, and they have very similar pHs, 6.0 and 6.1, but the levels of these potentially toxic micronutrients, iron and aluminum, are very different. So if you look at your pH from year to year and you see minimal changes, don't worry. Any change in the direction you want to be moving is going to be a good change for the nutrients in your soil and the balance of your soil. So then we're going to look at the soil organic matter, and this is your water and carbon sink. So soil organic matter promotes just overall soil health. It really helps with soil structure, helps retain water, which is good during the drier summer months. It provides homes for microbiota and allows them to create soil structure. Increasing your soil organic matter levels can also eventually lead to greater nutrient retention by increasing the CEC, which is something we'll talk about in just a moment. But that does take a while, so it's important that you keep up with your soil organic matter and keep trying to build it and promoting that nutrient cycling system. However, there really is no optimum level for soil organic matter. Finer soils are going to retain more and sandier soils are going to retain less, just as a general rule. You want to make sure in sandier soils you have at least 2% SOM, and then in heavier soils you want at least 3 to 4%, but those are pretty minimum levels. Generally speaking, the more you have, the better it is, for the reasons that I listed before. It just promotes soil biodiversity. Soil nutrient cycling works better, water holding capacity. Essentially, it makes soil from a sterile medium into a really biologically active, structurally sound plant medium for growth. So now we're going to look at the cation exchange capacity. This may seem like a complex concept, but it's not so hard to understand once you get the basics of it. Essentially, what it means is cations or nutrient ions, so things like Ca2+, calcium ions, and magnesium, they're stored on exchange sites on soil particles, which are just negatively charged broken ends of molecules. And that's what allows the soil to retain nutrients and exchange them with the plants and the soil water. So finer soils, because they have more of those edges, because there's more particles, have higher cation exchange capacity, generally speaking, whereas coarser soils like sand, they have less surface area, so they have less of an ability to retain those nutrients. That just means that if you have a sandier soil, you might need to be applying more nutrients, taking that into account, taking leaching into account when you're looking at your soil test results. But like soil organic matter, a higher cation exchange capacity just means more nutrients for your plants. And clay soils are going to have a higher one, and sandier soils are going to have a lower cation exchange capacity. But there is a big problem here. Our soil test results don't tell you the texture of your soil. So that means you don't know if your cation exchange capacity or your soil organic matter percentages are really low or high unless you understand your soil. So there are some things that you can do beyond your soil test results to get to know your soil better and understand how nutrients are cycling within it and how it's going to react or how it's going to retain nutrients, water, things that are really important to plant and biological growth in general. So here's a list of some things that you can do without a lab. They're not going to be 100% scientific or super accurate, but it's good enough for government work. It works, and you can understand, okay, am I working with a sandier soil or a heavier soil? But if you want to look for these things, it is a really good idea to stick to those same sampling zones that you use for submitting soil samples. That just keeps you consistent. So the first thing we'll talk about on that list is soil texture. This is another one of those master indicators like pH, at least I think of it that way. It's really it's really vital for understanding how your soil retains nutrients and water. Heavier soils, clayier soils retain more of those things. Sandier soils retain less. They're more susceptible to leaching. Clay soils are more susceptible to ponding. So you can do this a few different ways. You can go online with tools like Web Soil Survey or Vermont A&R Atlas, or you can go outside and use some of those soil tests or soil samples that you got before and perform some tests at home. It's really not super difficult. There are a few different methods. I've listed them all with links at the end of this presentation. So if you want more details on those, just check out this presentation afterwards. But going online is a perfectly acceptable alternative, and it'll give you a general idea of what's going on in your soils. For everything else, like drainage or slope or aspect, you're gonna wanna go outside. Really just look around. It's easy to assess slope relative to other portions of your property. So, you have a hillside that's steeper, you have a depression in the landscape that's collecting water, and you know that those things are going to affect how the soil in that area reacts to retaining things like water or soil organic matter. You can also assess those things online, but quite frankly, it's pretty easy to go outside and do it if your property is not massive. So let's go outside one more time and actually do that ourselves. We'll look at some of these soil properties. So let's look at this landscape here. We can see we've got a depression, so we can tell right away that there's likely some poor drainage going on, probably accumulating clays, organic matters, things like that. Then we've got a slope over to the left side. It's probably pretty well drained. Water runs right off of it, so it's probably not going to retain smaller, finer particles as well. And then we've got a flat area, and it's a little more difficult to figure out what's happening on that flat area if we don't know the soil texture and structure. So let's dig a hole in the ground, pick some soil up. And what we can see here is that this soil has some nice granular structure. It's got lots of pores. It crumbles easily in the hand, but the smaller chunks of soil still remain together. And it's got a really nice dark color. And what that tells us is that this flat area of our soil has good structure. There's probably lots of organic matter because there's solid aggregation going on. It's got a dark color to it. So this area is probably going to be relatively well drained. So we don't have to worry about ponding or other issues like that. But it looks like that it also doesn't have trouble retaining those smaller particles. So we could talk about assessing overall soil health at this moment, but that's a little bit more complicated and not within the scope of doing this 2D presentation. So let's go back inside and look at some options for doing that yourself at home. There are a litany of these soil health worksheets. This one is from the Massachusetts NRCS, but basically these are scorecards that are in plain language. They don't have any jargon, and it's basically a way for you to go outside, look at your property or your land, maybe dig a hole or two and really assess what's happening without having to pay for additional complex soil testing that might not tell you anything beyond what you can do by going outside and digging a hole. And then for your benefit, definitely keep a journal of your soil test results, what you do from year to year, and just any of your observations that might pertain to the soil. It helps you track your progress. It helps you notice problem areas. If a service like Extension comes to your property, you can show them this, and that will help them provide recommendations to you and your land. It's just generally a good idea. It doesn't have to be formal. It can be an Excel sheet. It can be an old notebook, whatever works for you. So that concludes my portion of the presentation. Thank you so much for listening to me. And then please write any questions that you have for me in the Q&A. I'll answer them live or on the app. So I will hand it back to Laura.
So Laura, is there anything like more specific that you just want to cover real quick, or we have a couple of applied questions that we could go through too? It's kind of up to you, I guess. You're muted, sorry.
Thanks.
Okay. I just wanted to suggest, Laura, I just want to suggest something. If there's a bunch more that you want to do, maybe we can, and if there's not, okay, because we could.
No, yeah. There's just one thing I was going to show, and then we can leave it to questions, if that's okay. Let's see. Let me just bring it up. Where I can't see my pointer. There we go. Share. Sorry, guys. For some reason it didn't go. There we go. So can everybody see my screen? Okay. So the only thing that I think I would want to just highlight before opening up to questions is many of the folks that I work with are maybe they have soil test results, maybe they don't, but they are generally out there applying manure or having manure applied to their fields. And I think that a lot of times folks aren't quite sure how much something like nitrogen is being applied. And that's a nutrient that is, really going to show a response in your forage yields. And this chart or spreadsheet that I've got up here is just kind of a brief case study of only semi-solid manure being applied over a season. And this is from a 40 cow conventional dairy that has an excellent grazing system. They hay, and they also have some conventional corn that they feed out. And their hay field recommendations were 160 pounds of nitrogen, 90 pounds of phosphorus, and 180 pounds of potassium. And they did a split application of 3 applications at 5 tons an acre using a spreader like the one pictured here. And they also knew the content of their manure, the nutrient content of their manure, which I've also listed here. So we've got NPK, the recommendation, and then what the content of the manure was in NPK. And they were applying at 5 tons an acre. So in each application, I'm just going to use nitrogen as an example. They were applying about 14 pounds an acre. And by the end of the season, they applied a total of 42.6 pounds of nitrogen. And so that is not what the recommendation said. They're lacking quite a bit. So, but that, I don't think that should send out an alarm for people. I think that if you are getting the yields that you need with those manure applications only, then that's really what matters. But if you're feeling like it's lacking still, you can use something like urea if you're not organic, and supplement that extra lacking nitrogen. I'm just focusing on nitrogen right now in order to make up that difference. So I just wanted to show that example. So if you're only spreading manure, and of course it's going to depend on your manure and at the rate that you're spreading it, but this is just an example of what it might look like in terms of what you're actually getting down. So that's all I wanted to say. And just to remember, like, yeah, that's okay. It might not matter for you. It really depends on what your needs are. So I will stop sharing there. And
Awesome. Laura, we have one, probably time for just one question.
Okay.
Because we have a hard stop at noon. So
Perfect.
there's a question from Huva about what kind of test folks should get as a pasture manager. So the question is asking about more specific tests that folks could get: biological activity, CO burst test, organic matter percentage, breakdown of micronutrients. So I guess what would you recommend for a pasture manager that's trying to address herd health issues or other things that maybe a regular, just a straight up soil test doesn't address? What additional things might you recommend?
Well, I know that there are labs out there that look at whole soil health tests, like the Cornell. Cornell offers a more intensive soil assessment health test that you could do. They tend to be a bit more expensive. So a test at UVM, I think, is about $15 right now. But if you get a complete soil health test from Cornell, I believe, you'd have to look, but I believe it's something like $85 to get that sort of test. And that can kind of clue you in on other soil health parameters like permeability, soil texture, like Maggie was talking about. And there's also labs that do look at the biology of your soils and kind of, and I do believe maybe Cornell, that's a component of that soil health test. But there's other labs that do that as well. And I haven't worked a lot with those sorts of soil test results. So I don't have a lot of input beyond the fact that those are other options that you can explore. I think what is helpful too is to make sure that whatever route you decide to go, that you stick with one lab so that you can compare results over time. And then also you can assess visually in your fields how things are progressing or not. That's my response.
Awesome, thanks. And then there's another question here, just asking, commenting on how you were talking about feeding forages before in your soil health test. And this person is wondering why we're not talking about feeding soil biology as well. So if you have any final thoughts.
Yeah, that's a great, that's a great observation. And I think that it really depends on your philosophy and how you choose to look at how you're managing your fields. And if you're using organic amendments like composted cow manure or cow manure from the local dairy or any sort of organic amendment, and I don't mean certified organic, I just mean amendments with organic matter or compost or whatever your resources allow for, I think that that's a great focus to dial in on in terms of, feeding your soil health or the biology within your soil in order to improve your forage results. So I think that's a great point. Thank you.
Yeah, sure. Okay, so it's noon. Maggie and Laura will look at all the questions in the Q&A. And for folks just in Zoom, I'll try to get, Susie has been trying to get some of those in the Q&A and Huva as well. That's where those answers will be. And I think that's it. Thanks everyone for joining us.
Thank you.
Thank you so much.